All right, good morning. Today is Monday, September the 13th. This is our last official lesson of Unit 1. We have a review tomorrow, and your test will be on Wednesday and Thursday. We will then start Unit 2 on Friday. How exciting. All right, all of you should have this written down in your notes somewhere. You may have to pause this and come and write it down or snip it and then continue. If you're watching the recording, that is. All right, let's get started. All right, today we're going to do, well, we're going to go over graphing rational functions. Even though we've done this, I think, last week, today is more of a review than anything. All right, make sure you have your paper, pencil, graphing tool, and then, we should already all be up to date with all of these right here. I will be going over domain and range. I kind of covered it a little bit last week, but I'll go over it today again. All right, let's look at this one. So, guys, I have lots and lots of examples. So we're going to focus on this one for most of the class period because it seems to take that long. All right. So on this page, I have these three to find, and then on this next page, same problem. We'll be doing these three. All right. So let's find the x and y intercepts first. All right. How do we find the x-intercepts? What do we do, class? Anybody? All right. How do we find the x-intercepts? There we go. So somebody has this snipped in their notes written down. Yeah, we set the numerator equal to 0 and solve. So going back to this first page, right? Remember? To find your x-intercept, we set the numerator equal to 0 and solve. Yeah, all of you should have this cheat sheet in front of them. Or you should know this top of your, the top, back of your hand. You should know like back of your hand. But preferably you have it snipped or written down in your notes because you'll need this. All right, so everyone find your x-intercepts. Give all of you like, I think 1 minute to find the x-intercepts. Yeah, really should have it written down in your notes. All right, what did everyone get for your x-intercepts? So -1 and 2. So intercepts written as coordinates. When I ask for intercepts, they want a coordinate. So negative 1 comma 0 and 2 comma 0, right? All right, how do you find the y-intercepts or y-intercept? You said x equal to 0 and solve. Yes. So when you plug in 0 for all the x's, what is the y-intercept coordinate? See, a lot of you are tabbed out. Remember, guys, if you're going to come to class, make sure you're actually participating, right? No point of coming to class and just not doing anything. You can leave and watch the recording later. All right, Enzo got 0 comma negative 2/3. So to find the y, and so B also got 0 comma negative 2/3. Yeah, you have to include the denominator too. So going back to this cheat sheet that everyone should have written down. Whoops, wrong page. Written down in your notes. It says plug 0 into all the x's and solve. Yeah, it says all the x's, not just numerator. So yeah, when you plug in 0 into all of the x's, you get 0 comma 4 over negative 6 reduced is 0 comma negative 2/3. All right, so let's factor this entire thing. So everyone, I want you all to factor. Well, you should have factored this. Well, maybe not to find the x-intercept. Well, yeah, you would have to, right? How did all of you factor the numerator when you found your x-intercepts? Or what did you do first? GCF a negative 2 out. All right, yeah. Take out a negative 2. Not just a 2, a negative 2. So we get negative 2 out in front. X squared minus x, and then minus 2, right? All right, then how did you factor x squared minus x minus 2? Simple method. And what are those factors then? One and negative 2? So remember, they need to add to negative 1 and multiply to negative 2. So I would agree with you, positive 1 and negative 2. All right, and let's go ahead and factor the denominator. Also simple method, right? All right, what are those two numbers? Just like Isaiah says, -1 and +2. Oh, actually, that was for the previous one. So how do you factor x squared plus x minus 6? -2, +3? Sounds right. -2 plus 3 is +1, and -2 times 3 is -6. Yeah, I would agree with those. All right, so there's the factored form. All right. Before we do the VA, let's do the HA. So looking at the original problem, what is the HA? Go ahead and write it in chat. Remember, HAs and VAs are equations, so just a number is not enough. So y equals -2. So this is an even function, right? So we take the ratio, right? So it's -2 divided by 1. There we go. Yeah, y equals -2. Y equals -2. All right, class, how do you find the VAs or the possible VAs? What do we do? We set the denominator equal to 0 and solve. All right, so we already have it factored. So what are the possible VAs? Go ahead and write it in chat if you could. What are the possible VAs? X equals 2 and x equals -3. Yeah, so remember VAs and HAs are equations, not coordinates. So your VAs and HAs should be in the form of y equals or x equals. Yeah, only intercepts are written as coordinates. So again, intercepts are coordinates. HAs, VAs, SAs are equations. Make sure you get that right on your TGA. So yeah, your VAs are x equals 2 and x equals -3. At least maybe they are, right? There's a chance that we could have a hole, right? All right, something that I want to point out to you here. So, you may have seen this if you did the practice problems last week. So we derive our x and y intercepts, our HAs, our VAs. Now we factored it. So remember, one of these could be a hole, correct? Which one is the hole? X equals 2. Why? Why is x equals 2 the whole? How do we know? It's also in the numerator. Yeah, so we look for duplicates, right? So we have x minus 2 and x minus 2. So this tells us, since this repeats, that tells us that this is not a VA, it's actually a hole. So we're gonna cross this off, right? Actually, I'm gonna use red to cross that off. Yeah, we're gonna cross that off because it's a hole, right? I'm gonna jump to this page real quick. So we know the hole is located at 2 comma something, right? So we'll come back to this and calculate that. Also, I wanted to point out something that I didn't mention last week. So we put our x-intercepts here, and then this is our y-intercept. Something I didn't explicitly say. When you find your VAs and we identified the one that is the hole, which is at x equals 2. So if it's a hole, it can't be a VA, right? But also, if it's a hole, it can't be an x-intercept. So this 2, 0 is not an x-intercept because it is a hole instead. I didn't mention that last week, but any of you actually, when doing these problems, realize that if it's a hole, it can't be the VA like we said, but it also can't be an x-intercept. Did anybody make that connection last week when doing the examples on their own? Some say yes, some say no. But does it make sense? You can put in chat. Does it make sense of why it can't be an x-intercept if it's also a hole, right? Yeah. Yeah, so again, we look at these matching factors, right? So that tells us it's a hole. Now, if it's a hole, it can't be a VA, and it also cannot be an x-intercept. It can't be a solution. It can't be a 0, right? So, and I didn't say that last week. So that's important to know. So we're going to cross it off from our x-intercept list. We're also going to cross it off in our VA list because it's a hole. All right. So let's go ahead and let's plot. Let's plot these points. Everyone plot on your graph -1, 0, and let's plot 0, -2/3 as these two intercepts. So we have -1, 0. That's going to be right here. Oops, I'm going to use blue, not red. Back. And then we're going to plot 0, -2/3. -2/3 is like negative 0.6 repeating. So that's going to be like, I don't know, right here maybe. Close enough, I think. Close enough. All right, then let's also, everyone on their paper, go ahead and graph the horizontal asymptote. So graph the HA. Now this should be a dashed line, preferably in a different color. I'm going to use, I don't know if that's green or yellow. It's one of the two. So at y equals -2, everyone graph that line. And it should look something like this. So that is your HA. And then let's everyone go ahead and plot your VA at x equals -3. So it looks like it goes right here. All right, how's everyone doing so far? We calculated the x-intercept, the y-intercept, we found our VA equation, we found our HA equation. And we also plotted them. All right, guys, by the way, this is a TGA problem. This is, you're gonna have to do this on paper for me. And I expect to see, all your work, no work, no credit. So, I expect to see your factoring work like we did here. You don't have to, write your list like we did here, then cross off the one that doesn't work. You can just put these. I don't need to see what we did here. But, in your final answer, I expect to only see this and only see this for your x and y intercepts. I expect to only see this equation for your VA and to see this for your HA. You don't have to tell me for HA that, this is considered an even function and therefore we do the ratios. If, I I can imagine that most, if not all of you, could go right from this to this answer. Now you might show your work. You might put y equals -2/1 and then reduce it to y equals -2, and that's fine if you want to show that extra work. If these numbers were a little bit bigger, maybe I would expect to see at least the setup and then the reduced answer for the equation. But and then on your graph, we plotted the x-intercept coordinate, the y-intercept coordinate. We graphed the VA dashed line, the HA dashed line. So everything I expect to see on your TGA problem to get full credit. Yeah, you can circle your answers. That's fine. Yeah, just make it clear to me. Like, when you submit an answer, it should be clear to me that you know that that's the final answer, right? Yeah, as long as it's clear to you, it's clear to me. I'm okay with that. All right. Before we go on to doing the holes and everything else, I want to talk about domain and range. Even though I have it on this page, we're going to do it on this page here. So last week I did talk about how your range is derived based off of your HAs. So again, the horizontal asymptotes, this is what it's derived on. Actually, let me come back to this because we actually need to know what the hole is as well to figure out the range. So I'm gonna save that thought. We can do the domain though. The domain is really easy. It's based off our holes and our VAs, which we already know x equals 2 for the hole. So your vertical asymptote for this one, oops, use blue. Always least to greatest is from negative infinity to, all right, what's the next number I should put? Remember, domain is everything but our disconnects, right? Remember, it's always least to greatest. So which smaller? Negative, well, shouldn't even have -2 as a choice, right? Yeah, so -3. Yep, he's right, -3. And then there's our disconnect. And then what's the next number in our sequence? Remember, domain is x values. 2. Yeah, so there's the hole at x equals 2. And then from 2, where does it go? Positive infinity. Yeah, we include the hole. So remember, the domain is the x values and including all the disconnect. So we have a VA at x equals -3. So there is your first hole or your first disconnect. And then from -3, it goes to 2. So 2 is the next disconnect. We don't have it graphed yet, but we're going to have a hole somewhere in this area. And that's where the next disconnect happens. And then from 2, it goes to infinity. So yeah, so domain, you utilize your VAs and your holes. And I think I have that on the cheat sheet. If we look back at it, use the VAs and the holes to construct. So the range, I say use the HA to construct. There should be like a little asterisk right here, and we're going to talk about that in a moment. So we use the HAs, but we also need to use a hole, maybe, and that's where the asterisk comes into play. So let's go through that one. Everyone, let's calculate your hole. So we're going to use our factored form, right? Try to remember what we did last week. Hopefully you practice and it's, well, it should be easy to remember. So everyone do that. And as you're doing that, I'm going to copy this to the next page. I'll give you another minute to finish up the whole equation or the whole coordinate. We are calculating the whole, that coordinate. All right, looks like time is up. See, people already have. Two comma negative 6/5. I would agree with you. Yeah. So remember, when you plug in 2 for x, these two factors cancel out. So we're only plugging into this x and this x here. So let me just go ahead and show that. So we plug in 2, the 2 x's, and we simplify, right? So that's a 3 on the top, and then that's a 5 on the bottom. So negative 2 times 3 is negative 6, and then, well, 5 on the bottom. So yeah, that's how we get negative 6/5. All right, so let's go ahead and let's plot that hole. Oh, below that, let's write that in decimal form. So remember, on your TGA, your test, I don't want to see any decimals, but we're going to write it in decimal form just for us to see, so it's easier for us to graph it. It's the only reason why we're going to have decimals written down. So yeah, so negative 1.2 is the decimal form. But for your final answer, when it asks for the whole, I do want to see 2 comma negative 6/5. So everyone, let's go ahead and graph that hole on the graph. 2 comma negative 1.2. So it looks like, I don't know, like right there. Hold on, that circle's not very good. There we go. That's a little better. Good enough. Good enough. All right. So on this page, I'm going to just write the whole coordinate, which is equal to 2 comma negative 6/5. Okay. All right. Does this equation, this function, does it have an SA? It does not. So why doesn't it have an SA? Because the leading exponents are equal. So how would we know that it has an SA? If the top one was one higher, yes. So this one would have an SA if this exponent was 1 degree higher than this one. And this is 2 and 2, they're the same, so there is no slant asymptote. So we just, for the SA, we would just say none. All right, now let's go back and sketch the graph, and then we'll derive the range. All right, I would suggest going into Desmos and typing this in to see what it looks like, because we created kind of like the skeletal framework to graph it, but let's see what it looks like before actually drawing on here, because there's really no way unless you do a bunch of test points to graph this. So when you go to Desmos and you type this in, you hit enter, you're going to see that you get this line that kind of passes through these points, right? And then you see another one that kind of is down here somewhere. So I'm just going to write that sketch. I'll use blue again. I should have made my points a different color, but it's okay. All right, so it looks, something like that, and then it goes up, right? So in Desmos, it does that. And then we see like this other piece right here. Not accurate, but good enough. All right, now for the range part. So we sort of need to use the holes to also derive the range like we did with the VA. But you want to use the Y value. But this isn't always true, because sometimes the graph will have some overlap. But this one only has 2 parts, so it's kind of easy to see that at this point, this Y value, if we draw a horizontal line, there's no other point that kind of fills this gap, this disconnect. So your horizontal asymptote will go from negative infinity to this HA, from the HA to this hole, the Y coordinate, and then from that Y coordinate to infinity. So everyone in chat, go ahead and write down what you think the range is going to be for this. And I really think on your test, I don't think you actually have to derive range. I think it only asks you for domain, but today we're still going to do range. So Enzo says from negative infinity to -2 union, -2 to -6/5, comma, or not comma, union, -6/5 to infinity. And he would be correct. Yeah. Yeah, so this goes from negative infinity to -2, union, -2 to -6/5. Oops, let me move. I just have to delete this on the next page. union -6/5 to infinity. So, this one's a little trickier because it also uses the whole, maybe, but it uses, remember, range is the y value. So that's why it uses the y value. But this is not always the case. It really kind of depends on the graph itself. Because if you did, like I said before, a horizontal line through that hole, it wouldn't pass through any other points except that hole. So that tells us there's the disconnect. I wouldn't dwell on the HA too much, just because, like I said, this class, and well, most classes really just focus on domain. What are your inputs? What are your valid inputs? Not necessarily what the outputs are, but you will probably have a few questions, but it won't be confusing like this. Like, this is, I wouldn't call this tricky or confusing, but it's very easy to miss this whole, this y value here, -6/5. Yeah, it's a little, yeah, definitely tedious. This question right here is very tedious, only because there's a lot of steps to it. So to kind of recap this problem here, we had to factor it. We had to find the x-intercepts by setting the top equal to 0 and solving, which we found these. To find the y-intercept, you plug in 0 into all of the x's and solving. We got 0, -2/3. The HA we found by looking at the leading coefficients to see if they were the same, which they are. If it was one higher, or not, sorry, not one higher, but bigger on the top versus bigger on the bottom. And remember, there's three scenarios comparing the exponents. This happened to be even, so it was the ratio -2 divided by 1. Reduced, we got y equals -2. The VAs, we set the bottom equal to 0, and we solved by factoring, and that's how we get x equals 2 and x equals -3. One of them was not a whole. Oh, sorry, one of them was not a VA because it was a whole, and we know that because we have matching factors. This tells us there's your whole at x equals +2. So we crossed that off from the VA list, and on the next page, we showed that worked to actually calculate the whole. Also, because it's a whole at x equals 2, it can't be an x-intercept. So we actually had to go back and cross this one off too. A lot of things to remember here, right? But really, if you go to Desmos, we can see by Desmos that we do not have an x-intercept at 2, 0. That's why you always want to graph these in Desmos to kind of confirm what we have written down. And, it doesn't cross the x-axis at 2, 0. So just based off Desmos, we can cross it off. But the real reason is because we have matching factors. If you graphed it in Desmos, it should look like this. And we can see it only has one x-intercept, and then here is the y-intercept right here. There is the hole in the graph. Here's our VA. Here's the HA. And here's the other part of the graph that's in this little, I guess, quadrant. All right, somebody asked last class, how do you get vertical lines in Desmos? And you can hold you hold your mouse click on the actual color, and it allows you to change the line type from solid to dashed. Kind of neat, right? You can also plot a point in Desmos and change it to a hollow point. And of course, we should all know how to change the colors. So, yeah. All right. How's everyone feeling about finding all those parts and graphing it? It's a lot of work, but piece at a time, right? Piece at a time. And of course, always use Desmos to confirm what you have written down. This really summarizes the story for us. All right. Anybody know how to change colors in Desmos? Or Isaiah, have you even tried? Yeah. Enzo says you go to settings once you have it graphed. Then click on the circle. Yeah. Yeah. Give it a shot. I don't really like GeoGebra. All right. So that took up a big portion of the class, just going through this piece by piece and having you guys work on it. All of you should have practiced all of this last week and even graphed it last week too. So the rest of this, today's lesson, I'm just kind of going to flip through these, but I have lots of examples here. Like these four, I asked for the X and Y intercept. And then I have the answer key for those. I have four more questions asking about the HAs, and I have the answer key for those. These problems are asked for the holes in the VAs, but on this page I only have, I think, the holes written out. So yeah, these are the equations of the holes. This page I asked for the SAs, and I have the answer key for those as well. This right here talks about domain and deriving the domain. And I have the answer key for those as well. And then these last four, they want you to graph them. So you got to kind of do everything. So individually, and then I have the answer key for those. These answer keys don't have, like this right here. I didn't graph the slant asymptote. I should have. It should be a dashed line showing the SA. So I don't have that graphed for number 22 for the answer key. And then on the last two examples, we graph these. We show all the parts. And again, the answer key for these, I don't have the SA graphed for those. So keep that in mind when looking at this answer. I'm missing the SA dashed line. So I'm going to go ahead and I'm going to put the PDF in chat for all of you to download. So this would be good to go through and work through some of these problems. And then obviously you have the answer key to check your answers. But lots of practice. So we have about, looks like 11, 12 minutes left. On the ones I kind of really quickly went through, are there any of these you want me to talk about or explain, show the work, or give you guys time to work through? So download the PDF, kind of flip through it. So that link I sent you, when I click on it, oh, that is weird. You're right. That is super. I thought it would actually give you a PDF file. Can you download this file though? Yeah, that is super weird. I think it used to actually give a PDF file and not this like browser. Well, at least you have the link and you can look through it. Yeah, so it still lets you to click through it. It's just not in an exact PDF file like I thought it was going to be. That's too bad. Well, if you don't have any questions on any of those right now, message me on Skype or email me. But work through some of them. Check your answers. And then I will see you all tomorrow for the Unit 1 review. All right, everyone take care.